Well, first of all, thank you for coming to our session. We're here to talk about lessons learned from running a multi-tenant Kubernetes environment in the financial sector. And above all things, everything today is personal opinions of myself and Mike. So I guess we'll just kind of get into it. So what we're going to talk about a few things are how we do manage configuration drift amongst clusters, how we do seamless lifecycle management, how we do alert-driven auto-healing, security identity stuff, and a bit about resource utilization, the probably easiest problem, right, in all of Kubernetes? No? Okay. First of all, I guess everyone here, anyone use Kubernetes or run Kubernetes, or are you a consumer? So maybe one more first one. Who's a consumer? Anyone a builder of or manage? Okay, cool. So I guess let's dive into it. A little bit about us.
Yeah, so a quick intro. I'm Michael Shelton. I am the lead engineer and architect for the Kubernetes platform at JPMorgan in the infrastructure platforms organization.
My name is Serhat. I'm a principal software engineer at JPMorgan Chase. I work mostly on our Kubernetes platform, starting with core development, doing a lot of SRE, everything we can to make sure the platform is stable, and now kind of like what's next, which is maybe a talk for hopefully next year. So let's kind of dive right into it. So to handle configuration drift, we look at a few different things on the cluster. You have nodes, and you have the applications and pods running in the cluster. So to focus a bit on nodes and the physical infrastructure behind it, we kind of lean into a repaving process. And you might look at this diagram and kind of wonder what it actually means. So we kind of, in theory, like to do repaving based off of a highway, like repaving. So if you've ever been driving down a highway, how they do repaving, they'll like drop some cones in a lane to let that lane empty out before they rip it up, kind of repave it and put the lines back in. So we follow a very similar process using native features of Kube. So we use the drain feature, essentially putting up the cones to allow application pods to move off, make sure no new workload goes on there. And then we'll wipe a node, rebuild it, put it back in, and paint the lines, essentially putting it back where it is. Was it a control plane? Was it an egress node? An egress node, some sort of specialty function. We liked repaving because it was something we could automate fairly easy. It provides a lot of benefit of kind of fresh machines, but also a little additional things that we get kind of off the cuff, right? So essentially get chaos testing for all of our applications because we're consistently moving applications around from node to node. We learn a lot about application architecture and how application teams can handle that. We can do new rollouts of OS versions by following this process. So we'll just kind of update an inventory saying we need this new OS version rolled out, and essentially repaving kind of lets that process happen. So it's not only just about the good, and we could also kind of deal with things like CVEs. Of course, they exist. Wish they didn't, but we have to deal with them. And sometimes patching a CVE becomes problematic. So we use this similar process. And also for how we do upgrades in the cluster, which we'll kind of dive into a bit more in detail. And the cool thing about how we instrumented this process is it's adjustable, like the rate at which we do it, so we can be very aggressive or very slow. So if we have, in theory, had a 0 day that we wanted to patch immediately, we could, in theory, repave an entire cluster without disrupting the actual state of the cluster. So etcd stays in state, all the applications stay up and running, and it's up to working with application teams, ensuring they follow like resiliency patterns to be available to all that. And then once a year, we actually wipe the entire state of an entire cluster, all the info, everything, and put it back on. And then kind of the second half of with configuration drift is really what's in the cluster. So we do code releases roughly weekly to about 200 clusters. We follow a heavy promotion process to ensure the safety of that cluster and all the applications running on there. So we have kind of concepts followed in the industry like canaries and things, and we follow a promotion process. So eventually, over time, we have about 4 releases running across the estate. Production is always the same. We instrument these processes heavily with telemetry to let our automation kind of watch over and heal processes that fail. And what we did is we kind of built a system for us where a code version here ties to a Kubernetes version as well as a set of subcomponents, and we just major release our component every time we upgrade Kube itself. Pass over to Mike for a minute.
So lifecycle management is a difficult thing to manage, especially in the Kubernetes world, right? So doing a Kubernetes version management and seamless rollout is something that took us quite a bit to work through. We built a process that is fully automated and metric driven to upgrade our estate of Kubernetes clusters. we split our clusters through resiliency patterns through different groups, and it allows us to upgrade, group A, and then move to group B once A is done, and C, et cetera. And it's all driven off of Prometheus metrics. Eventually goes to Cortex. We need historical lookups and things there. And basically uses that metric as a threshold, whether or not is the yes/no trigger, do I upgrade or do I not upgrade? And this also traverses environments and data centers and different, like I said, resiliency patterns. And this is completely seamless and really behind the scenes to the users, right? So we do run a multi-tenant, multi-cluster namespace sort of as a service architecture. So we'll upgrade these clusters in place, really without the users even knowing. We try to align to the upstream Kubernetes cadence, doing 3 upgrades a year. It's a bit of a challenge, but we've accomplished that. The one thing that we do, I think, that is a little bit unique in that we actually only upgrade the control planes, and then the repave process that Alan just spoke on actually takes care of upgrading the nodes themselves. So we upgrade the control planes, and over the next whatever couple weeks, as the nodes get drained, cordoned, destroyed, rebuilt, and put back in the cluster, they get put back into the cluster on the new version. So that way we don't have to try to upgrade a full cluster and all worker nodes all at once, and adhering to the Kubernetes version skew policy that allows the version diff between the nodes and the control plane.
Yeah, a few things we think about adding to that is Mike mentioned we do publish a lot of these signals out there for teams to consume. So teams can consume and follow along, which is helpful in a way. So what we do with grouping and how we group servers, teams might follow resiliency patterns to deploy an app to one group and another group. So this way they're not going to be hit with an upgrade at the same time. As much as we want to be super fast and super quick, we do want to work with businesses to ensure that they have a comfort level of their own. So that whole process with the telemetry is great because then they could kind of follow along, maybe judge it, and then essentially use that as an idea of how their app handles an upgraded version as well. So we don't have too many things that consume the Kube API itself, but we have that data out there for them. Just kind of move on. So one of the other things that we do kind of corollary to all these processes, what I mentioned, is we do a lot of telemetry in the space of not just CPU usage and RAM and the things that you might want to alert on and be observable on. We put telemetry into the processes of repaving, code releases, rebuilding, all sorts of things, and we have automation. So this is a very lengthy screenshot here, but what we do is when we build an alert for something, we build an additional alert for that previous alert that's coded for the automation system to read and understand what's going on. So say if a repave fails, an alert might fire saying it failed, but then another one will fire saying, there was a fail, it happened here, this is what you need to do, and if you can't do that, this is what you do next. So it's a staged thing. So it might be go try to attempt to repave it, maybe put a mitigation out there. If it can't and it's deemed critical, open it, page a person. If it's not, maybe just open a ticket. So automation is kind of the theme here you'll see in order to run a large estate at scale with not a ton of people. So this is something that we're probably super proud of because it just gave us the ability to move forward on things like more feature development versus keep the lights on management, because as anyone knows, maintaining any piece of technology is a tough balance between I want to get new features for my users and I want to keep a stable system running without as much intervention as possible. And this is kind of just a sample here, so we'll let it understand things and it's teachable, so we can kind of on demand roll things out. That was me dropping a mic, and I'm a horrible presenter apparently. Anyway, on that topic, if anyone needs mic management, I'm next door after this. So yeah, it's kind of how this works, and it's like I said, it's a very helpful process for not just your basic alerting and stuff. It really saves a lot of time. Another thing, managing, like Mike said, a multi-tenant environment. So we run all multi-tenant environments across all areas of the bank. We go with the zero trust model. So we use a logical ID that's assigned to an application as a boundary, and we use namespaces as the boundary. So a team in one namespace can't see stuff from another namespace. We start with blocking egress, ingress out, so you have to actually define in policy what you're using. It also gives like resiliency a better thing. So we don't have, in the past, you might have seen like you have an app deployed somewhere and someone needs to migrate and they're like, what port is it using? We're like, oh, I don't know. You wrote the app. Well, I don't know. And it's like this awkward conversation. They're like, well, can't you tell us? And we're like, well, it's your app, right? So in this case, we decided with this platform, we want zero trust. You have to declare what you're doing and why you're doing it, essentially. So if it's a migration process, it's a lot easier. Like I said, the namespace is our boundary. So we're essentially namespace as a service. Get a namespace, go deploy your app. We use things like SE Linux in enforcing mode. We use some standards that we find out in open source. We also use some custom policies specific to us. We use PSAs and PSSs in conjunction with a lot of different webhooks to enforce a lot of policy. So we run Kubernetes, vanilla, open source, and then we just have some policy in place, right? Kind of keep things going, and we're big fans of, in theory, OPA Gatekeeper as a policy enforcement engine. And one of the things that does come helpful, which is to help move in rapid basis, sometimes we'll exempt a platform namespace from certain policies to help us kind of gain traction, and then maybe as a feedback loop, go back and tighten those things up over time.
Let's talk about identity. So we utilize OIDC as the identity client for Kubernetes. In order to even generate a kube config to access a cluster, a user must have the proper OIDC entitlements, and or if they're using like a functional account, that functional account has to have set entitlements as well. And on top of that, workloads can also sort of assume an identity associated with that entitlement framework with the firm-wide directory. And this is all sort of seamless. It's passwordless, secretless. We do it with a mutating webhook that injects a sidecar onto their workload that then handles that identity ownership and communication back and forth with the identity provider as well as their workload. This obviously allows for a more secure way to manage that identity across different products and services. Say they have a workload that wants to talk to a database, they no longer have to manage credentials or certs or whatever that is that goes with it, and sort of just eliminates that risk in the risk area. For the sake of RBAC, we leverage RBAC, and that RBAC is actually tied to firm-wide systems. They have to go request the roles that they would like within the firm, and then that gets applied and ingested into Kubernetes RBAC itself, so that there's a sort of a mapping there, sort of a one-to-one mapping. So the pod identity, so it can be exchanged for other identities, in that like it's this pod can then now talk to X, Y, and Z services internal to that cluster, external to that cluster. It could be somewhere else. It could be Kerberos. It could be something we call like platform identity. And it's all, like I said again, all sort of seamless to the user. They basically drop an annotation on their workload and it does it for them, hooks it up.
I think that last note is probably the most important part. When wanting to implement things like this, which would take a lot of heavy lifting for the users, we look for ways for using simple features like an annotation or a label to drive systems underneath to make it a lot easier for our consumers. And this kind of ties in with our zero trust thing. We try to limit the use of secrets as much as possible because we all know how secrets are. Wait, no one laughed at that, man. Come on. I guess one of the last things.
And resource utilization and capacity management. So all of this is really talking about our private cloud Kubernetes estate, where there is a finite amount of resources around. So you have to be mindful of how to manage that, manage the capacity, manage the utilization of the capacity. We're probably 6 years into our journey in Kubernetes. Something like that, I think, right?
Yeah, I think we celebrated our 6.5 year.
The first year and a half, 2 years, getting those first app teams to move over from like the virtual servers or VMs into the container space it's a bit of a journey to change the mindset of how resources work in the container space. You have a lot of app teams that were running like Tomcat, Apache, web app servers, and they were running, say, like 4 core and 16 gig, and they're like, let me take this app and move it into a container, and let me request 4 CPU and 16 gig, and that was a bit of a journey to tell them, like, no, you need like a half a CPU and maybe 4 gigs of RAM, and they're like, I don't understand, you know. Thankfully, you know, over the years that's changed. That mind shift has finally sort of been moved more into the the container space. And you know, we put a lot of education sessions, a lot of dashboards, visualizations, office hours, et cetera, sort of, you know, trying to upskill and educate the user base on that, because it is a bit of a mind shift. You know, people have been doing this for decades, and suddenly now they have to completely change their mindset of how to allocate and request resources. So we use you know, resource quotas and limit ranges that are based in Kubernetes. Early on, before the hierarchical namespace controller was introduced, and I believe in 1.19, we built a similar concept of grouping namespaces together for the sake of resource utilization. We call it a resource boundary, and you'll see sort of just an example spec of a custom resource there. And this allows to aggregate resource quotas across a set of namespaces and ensure that it's essentially a quota on top of resource quotas. So they, like, a bundle of namespaces have to fit within the boundary set on this this custom resource. So that allowed us to sort of allocate slices of cluster capacity to an actual application while enabling them to have as many namespaces as they want. That was an important thing that we built that kind of helped us manage actual physical cluster capacity within the data center and be able to shard and split that across app teams fairly. So future things that we're working on, you know, obviously Keta is a you know, open source project out there that we're going to be introducing. It's something that you know, it's been out in the wild a while now. That's going to help, you know, better help resource utilization in a better way, right? It allows advanced metrics for auto scaling up and down, and in different fashions, right? So you obviously have the horizontal pod auto scaler that comes native, which, you know, does your, you know, primitive auto scaling. So we're going to be looking at other features to, you know, continually optimize the capacity that is currently there and make it easier on the users to efficiently use it.
Just to add the emphasis, this piece was probably the longest journey of the 6 years that is actually still going on. So all of the other stuff we talked about, introducing new technology, things like repaving and code deployments and making users aware, it's like that was almost the easier adoption. I think running Kubernetes was the easier adoption, but resource utilization is the hardest thing to convince people. And I'm just re-saying what Mike said, because that's probably a huge takeaway for people, is getting people to understand. It took mountains of people, a lot of metrics, a lot of dashboards, a lot of sessions to just kind of show what he said. Like, you have a 16 gig request and you're using 500 megs. Like, we gotta bring that down. Like, be greener. I'm going to talk quick, apparently. So that kind of wraps what we have really presented, and just wonder if has any questions. I see 2 hands, so got you in the back, and then
What is your system of record? Where do you keep track of versions, configs, etc.?
So I mean, that's all kept track and source control. It's all code driven behind, you know, your source control approval process, PR process, et cetera.
To kind of add, like, for that, what the upgrade stuff, in theory, we can go to that record, update the Kube version. So we have to procure some stuff into, like, internal registries, but we update, say, the Kube version, put a PR into master or main, and that kicks off a release process. So that if that builds successful, we merge it, a new tag gets created, and on a deployment day, it goes out, it just starts the upgrade. And if it fails, we know where in the pipeline, like maybe this component that we have didn't work with this version of Kube. We need to go fix those types of things, but it is all source driven. So
It's all GitHub, right?
essentially, yeah, we probably use a bit of Argo in there as well.
Oh, yeah.
Under the covers.
Yeah.
Do you run a separate cluster in each availability zone, or does it span?
So yeah, the concept of availability zone is sort of part of our DR pattern. I mean, so when we talked about maintenance groups, it's I would say basically the same thing as an availability zone in that sense. So yeah, and we push people to deploy into multiple clusters across maintenance groups, which is essentially, I would say, availability zones. So it's different groups in the same region. So we'll have like maybe 2 data centers in the Northeast, and they're like, I got to deploy to each. So we split those and say this is in group
But they're part of the
A.
same cluster.
No, they're different clusters.
Okay.
So we tell people to actually span multiple clusters
Okay.
for resiliency purposes.
And then
Also.
same for region.
Yeah, same.
We
for
work
region,
with
yeah.
like firm-wide like resiliency planning and cyber to kind of design where we lay things out to make sure that if an application team has to meet some sort of spec for whatever compliance or regulatory or risk or whatnot, that we have the layout for them.
And I mean, for the sake of actually in a single cluster too, a cluster does have its own topology and availability zones
Yeah.
as well. So that has its own failure domains.
Like from within how the data centers are architected.
Do you have any latency sensitive apps onboarded to Kubernetes?
I mean, as much as we can share, yeah. I mean, there's definitely things that are sensitive to latency. There's been some struggles figuring some of that out, but we definitely have apps. We have some apps that are sensitive, and they work. We got them working fine.
We do invest a ton in telemetry for
Yeah.
things like that. I'd say a rough number is multi-100 million time series produced to look across stuff. We want to know every single thing that we can, because we understand we can't know everything, but we want to know every single thing that we can. And when something goes wrong, if we do not have the signal for it, we will get the signal for it, produce that up there, and then with that whole alerting system, we'll drive generally either minimally some visible alert that there's a thing going on, go look at it, or a full mitigation. But for reasons like that, especially in like running multi-tenant and having different app teams and sharing a different cluster and noisy neighbor concerns, we rely heavily on telemetry. Big, man.
So, as you matured your repaving mechanism, you already have in place your application.
So when we do draining, the developers don't necessarily need to redeploy because that workload is just getting moved from one place to another. When we do like a destructive wipe, the deployment pipelines are there to handle that, and we partner with that team to make sure that we're not, killing the developer.
Was there a lot of rework that you have to do?
Probably a decent amount. I mean, over time, again, like in the first time we did it, when we did it, probably could share, like in our early beta, we wiped things once a week. Like before stuff was going to be GA, to give people a feeling of what it's like. So we did exercises with things that are not necessarily production processes. They're probably more disruptive and could cause more trouble to see like what's going to happen if we go and do this. We also, in the repaving process, we're brave enough to we wipe etcd regularly. Repave, rebuild, all that stuff. So I'll go back to that guy.
Yeah, I mean it's a very broad spectrum, right? We have a significant amount of people in our technology organization. I think we were somewhere over 2,000 application teams on Kubernetes. There's a broad spectrum of advanced users, beginner users, people who just want a place to deploy something, don't want to learn anything about the hosting platform. So it's really every part of that. We have developer relations teams that will engage with the app teams to help onboard them, maybe help bring them along and educate them on what they need to do in order to get their application running. A lot of this is instrumented through the firm-wide CI/CD tooling, to where a lot of it's abstracted away from the user, so they don't necessarily need to know a ton about low-level Kubernetes. They just, I need, if I need a secret, I do this. If I need a config map, I do that. Like, there's a lot of documentation and process for teams that they can go through and follow. So while they don't necessarily need to know it, we do advocate that. I personally advocate that an app team, if they're going to be running on Kubernetes, should have someone that like at least has a CCAD or has gone through and understands at least the course of a CCAD. Wait, say that again?
So
Like pod to pod across clusters.
So there's a couple different ways to do that. A lot of times it's out and back in, so it goes out of the cluster back. If it's going cross cluster, there could be service mesh. There's a couple different mechanisms to do that. Some people will use Envoy proxy, build a mesh that way. So there's a a lot of that's really on the app team of how they want to orchestrate it. But yeah, a lot of people will use load balancers and the global load balancers across, and they'll do the microservices on top of that. So they'll go out, layer 7 and back in through ingress. But yeah, it's a lot of different patterns for that.
Yeah, I was gonna say, coupling that with the last question, a lot of it is pattern driven too. So we'll publish patterns with application teams and architects and work with the lines of business to get as much consistency. And there's no one, we learned one thing with Kubernetes, there's no one thing that fits all. I don't know, man. Honestly, one of the things that definitely amazes me about the community is the community. There's, right, you have, there's all sorts of things, right? There's open source kind of things like something like a Kube spray. There's enterprise versions, all sorts of stuff. But regardless of what you're going to choose to use, the community is amazing. We work with the community a lot. We kind of, Mike spearheads. We have members of our engineering teams that'll like join SIGs and tags and things, being a part of it. And there's like no one that's shy to help. And like I think they said in some of the other things, it's open source, right? The sharing is amazing. And you don't see too many people like from another company being like, I'm not going to talk to you because I'm also in finance. Like that part is cool. And I think the upgrades are pretty seamless. So maybe we've just been doing them for way too long. I did my first one at 1.8 to 1.9, and we're on
127.
When 131 just came out, and like that, the process gets better. I don't know.
Yeah, and I mean, on the open source contribution bit too, I mean that a lot of people talk about contributing code. Open source contribution is also just about contributing participation, right? Joining those external communities, involving yourself, talking, participating, or even just listening, at a minimum. And I think that's a big thing that's probably not talked about enough at this conference.
Yeah. I'm just going to give that guy a chance, and we're also outside in the hallway after, by the way. I don't know what time we're supposed to leave here, but you're,
Did you contribute back into Kubernetes?
We haven't contributed to Kubernetes project specifically. Some of the components, Envoy and things of that nature, we have some people that are like I wouldn't say maintainers. I don't know what.
we have maintainers on some maintainers, and if anyone went to a session that was across the way earlier about open source at Chase, it's just an evolving process. There's a great governance now to help make it easier. In the past, it might have been a bit challenging.
Yeah, historically, it's been a little bit more difficult. It's getting much easier. You'll see a lot more of us in these communities and contributing code back up, probably in the next 6 to 12 months.
I mean, I've done like PRs to Prometheus in the past and things like that. So, kind of love Prometheus. We may or may not.
We don't mutate resources on users. We don't want to get in the way of accidentally causing application outages in that sense. We do put limits. So there's sort of and my personal belief, and I think Alan's with me, is much prefer using like validating webhooks and policies than mutating things. Mutating doesn't provide feedback back to the user of how to properly do something. So we'll put enforcement instead of changing. And so going back to the resource boundary custom resource that we built, that was a way for us to contain an app from actually overtaking a cluster and requesting too much. We had a weekly automated report that went out to all the app teams as well if they were over reserving, underutilizing, and basically highlighting like, oh, you're reserving X amount, you're under like the 20% utilization threshold or whatever. I don't know what the numbers are, but so that would go out every Monday or something that we would send to every app team that was in that window.
We also keep track of resource usage over time. So if there is a problem child, so to speak, we can use data as best as we can to put it in front of them. Ultimately, you can also use cost as a factor, but it's a challenge. And that's why I mentioned that's still going, right? There are going to be teams, no matter what, they just don't want to listen, and you're kind of stuck. Escalations happen and whatnot. We do our best. It's definitely not an easy ask. Do you have another question?
Sure, I got plenty more.
Okay.
Do you let your end users write their own like home charts, or is that how they write their what? Home charts.
Yeah, so the Helm charts is one of the primary deployment mechanisms for app delivery. Helm charts customize, and people can do static manifests too. So
Like the thing that we should mention, so although we are vanilla out of the box Kube, we do limit what resources people can use. So our app teams can't use a daemon source, can't say use a daemon set. So there's governance on like what resources, but how they provision that resource. I mean, if they want to write a bash script and do it, good luck getting that into your CI passed. But hey, we have a big separation also. After the platform is built, we'll take support and help, but getting an app deployed is not technically our problem to solve. Yeah, I think we are at
I think we're at
time.
time.
I'm sure. Thank you, everyone.
Yeah, thank you guys.